Okay. So till yesterday we understood about the RDDs, right? Now today onwards, like I'm going to start the data frames, which is core concept of the Databricks, I can say. Okay. So we are going to use these commands. The one I'm going to discuss from today till next week. So we use it regularly and day by day. Every day we use that one. Day in, day out, we use that commands. Okay. Okay. So what is that concept is? Data frames. Okay. Huh. Okay. So here, before you understand about the data frames, actually, you need to understand about the Spark context and all. Okay. So in a Spark, actually, let me write on here. So Spark is an object in the backend, guys. Just an object, like Python object, or like I can say scale object, you can call it. So inside Spark, so we'll be having actually Spark context. So yes, still yesterday we were creating that sc dot Spark dot Spark context sc equal to Spark dot Spark context we used to write, right? So that is part of the Spark object actually. So Spark context, and the SQL context and the Hive context are also there. Okay. So SQL context is actually deprecated. We don't use this one. See, the point why I'm telling this one is all the RDD operations or all the RDD methods actually we create from this particular context only. Okay, this is just an object I can say. Okay. Now inside this Spark context, we inbuilt we'll be having actually SQL context. So I'm going to talk about this one bit later, but I'm just giving you at a high level what are all these contexts are available in Spark. Okay. So we have one more thing that is Hive context. If at all, if you want to write the data to the Hive tables. So Hive is also one of the data warehousing concepts in I mean it's a data warehousing thing actually in Hadoop. Okay, when Spark, I mean, not Spark, I can say. So when Hadoop came into the market, we got that like Hadoop as a service, I can say. It is one of the Apache product, I can say. Okay, so what we do there is we simply store the data. How we are storing the data in a databases, right? In the same way, we store the data in a Hive. That is a data warehouse, I can say. Okay. Anyway, if at all, if you want to write the data, if you want to read the data from the Hive table, then we have to use actually Hive context. So in Spark 3.1 onwards, SQL context is actually deprecated. So actual data frames actually we need to create from the SQL context. And now we are not using SQL context anymore. We are going to use directly Spark object to create the data frames. That is what I wanted to tell you here. See, Spark, this is a Spark object. Inside that one, we have different objects are there. One is Spark context, SQL context, Hive context, like that, different contexts are there. Okay. So, anyway, for creating RDD, we need to have Spark context. Definitely, we need to do that one. That is what we have done yesterday. SC equal to Spark dot Spark context we have taken. And SC dot, every command, before every command, I used to use SC dot. Okay, now if at all if you want to deal something with the data frames, right? You don't need to write like sc dot a SQL context dot that command. We don't need to use that one. So SQL context is inbuilt in Spark object actually. Inbuilt is nothing but it's a part of the Spark object. That is the reason why we are going to use Spark dot going forward. Okay, I'll come to that one. I'll come to that one. Don't worry about that. Okay. So that is one thing. And I told you already, if you know SQL, Spark is very easy. Okay. So in SQL, where do you store the data? Where do you store the data?
Tables.
In tables, right?
Yes.
Same way, here we store the data temporarily, not permanently, I can say. We don't see Spark never ever stores the data. Spark is an execution engine. It takes the data from particular source. It processes the data, process means transformations, and it loads the data to the target. Target can be anything. Target can be database, target can be file, target can be some application, target can be anything. Okay, so it reads the data and it do the transformations and it writes the data back to the target. Okay, now what was it? Okay, so Spark does not store any data. That's what I wanted to clearly tell you first. Okay, so once it read the data, it stores the data in data frames, data frame objects, I can say. So I'm writing here DF, DF. Now going forward, I'm going to use the terminology DF. So your data frame is equivalent to table in SQL. Okay, table in SQL. But we don't store the, see, in table we store the data permanently, but in data frame we don't store the data permanently. We don't store the data permanently. Remember that. Okay, only for storing it temporarily we use that data frame. Okay, you'll come to know slowly that one. See how we are creating the RDD object, and after that RDD1 dot, RDD2 dot something we are writing, right? In the same way, data frames also stores the data in a table format indirectly. Okay, so this entire Spark follows actually MySQL syntaxes. I told you everything we are going to deal with SQL only. It purely follows the MySQL syntaxes. I mean, you don't need to understand MySQL now. If you know any SQL, that is fine. Oracle SQL, SQL Server, MySQL, or like PostgreSQL. If you know any one of the SQL, that is enough. See, 90% of the syntaxes are same in all the across all the SQLs. One or two commands here and there, it will change. That's it. Okay, mostly 90% it is same. Okay, best example I can say is if at all if you want to see the differential records between two tables in Oracle, what we do? We do select star from EMP1 minus select star from EMP2. That's what we write, right, in Oracle.
Yes.
But in SQL Server, what we have to write? Select star from EMP1 except we have to write EXCEPT except select star from employee 2. I mean, if you want to do A minus B. So only terminology here and there little bit change. That's it. Got my point?
Sure.
Hmm. So we are not going to use data frame, sorry, RDDs anymore, guys. We are going to use going forward only data frames. So we have different APIs are available in the data frames. Close to regularly used ones are almost 40 to 50 are there. If you understand about that 50 data frame transformations, you're good with Spark. Okay, so that is what we are going to do. Okay, so how many ways are there to create an RDD? What did we understand in previous to previous class? How many different ways are to create an RDD? Using parallelize method, we can create an RDD, right? Using sc.text file, we can use that method and we can create an RDD, right?
Yes.
Correct or not? In the same way, we can create actually data frame in 4 different ways. Guys, one more point before this one I wanted to tell you. Compared to RDDs, data frames are much faster in processing, in data processing, in transformations, I can say. So that is the reason why nowadays no one is using RDDs. But data frames backend data unit is actually RDD only. Okay, getting my point. Ultimately, it is going to convert that backend into RDDs. That you don't need to worry about that one. You just need to understand the APIs and use them whatever way you want. That's it. So data frames are much faster than RDDs because of the. So we have one concept actually that is catalyst optimizer. So that is open source framework actually. They introduced that in. I mean, they embedded that open source catalyst optimizer into Spark. Because of that, actually, these data frames are much, much faster than RDDs. I'm going to talk about that one also in the performance tuning, not now. Okay. Okay. So there are four different ways are there to create an actually data frames. Four different ways are there to. I'll tell you the differences also after discussing about the data frames. First, we'll try to understand about the data frames. Later, we'll just remind me in one of the class. I'll talk about the difference between RDD and the data frames. Okay. Now I'll not talk about that one because you need to understand the data frames first, right? Then only you can comment about the differences. Okay. Now, four different ways are there. I told you, right? So first way is actually using local objects. We can create data frame. Okay. Using RDDs also we can create data frame. If you have any RDDs created in your project, you can convert them happily into data frames. No problem. Okay. So third approach is actually from external data sources. That means if you have data in your CSV or Parquet or Avro file, or like if you have your data in database, from that also we can create data frames. Okay. Our last one is from the results of the queries. This one also I'm going to talk. So in real time, mostly we are going to use last two. 90% of the cases we use last two only. 90% of the cases. First two we don't use mostly. Because second one I told you already, we never ever use RDDs in our Databricks. Because Databricks doesn't support RDDs. I told you already that point. So second one anyway we are not going to use because of the RDDs concept. First one sometimes we use actually. Okay. So what we do here is if anything is not achievable, let's say you have complex requirement actually, you cannot achieve that one with the Spark. Spark are like data frames. So that those things actually we can achieve if you're able to achieve the like Python or like pandas, right? You can write even pandas commands also in Spark. No problem at all. Some of the complex issues, not complex, I can say some of the things which we could not able to achieve in Spark, we have handled in like pandas in our project. Even in the previous project also we used pandas. Not every time, sometimes I can say. If you know data frames concept in Spark, then automatically you'll get a knowledge on this one, pandas data frames. Because why I'm telling that point is the Spark data frames are actually derived, not derived, I can say. Spark creators actually took the inspiration from the pandas data frames only. The commands are almost look same. Look same. Okay, data frame commands, Spark data frame commands are almost equal to pandas data frame commands. Uh, Concept is same, but command wise, little bit here and there, like some changes are there. That's it. You can use pandas data frames also in your real time. Okay, that pandas data frames actually we can convert into Spark data frame. That is what my meaning here. Local object. Or one more meaning we have here. Local object is nothing but whatever the list tuple dictionaries you have, right? That also we can convert into data frames. Got my point? Any question before I move on to the actual execution?
No, sure.
Are we good? Okay.
Yeah.
So today I'm going to talk about the first two approaches. Tomorrow I'm going to talk about the third approach. Fourth approach we'll see a bit later, not now, not tomorrow. Okay, later in this week, like we'll see that. Okay. Um, okay. So first one is from the local objects, how we can create the data frame. That's what we need to understand. So you can create the data frame from the list. You can create the data from the dictionaries. You can create the data frame from tuples as well. Okay, let me talk about that one. Let's say I have the data set like this. One second. Ah, okay, let me go and execute this one. Okay, let me take the new one. New Python file. Okay, the moment you create a new file, you have to create a Spark object. Then only you can be able to execute all these things. Yes, Spark object is created here. Now I'm just copy. Oh, sorry. Okay, I can talk about that one directly, or like I can copy paste it instead of typing it. Hmm. Let's consider I'm just trying to take the data like this. Data equal to in a list actually. I'm just considering here a key value pair. Okay, so the key value pair Miller 25. This is employee name. This is employee age. Okay, so how we have sc dot parallelize command or sc dot text file command in RDDs. In the same way, we have the method called create data frame. C small here, D capital, F capital here. Okay, Spark. See here, for RDDs, I used to use sc dot, right? Always remember, for data frames, we have to use Spark because before Spark 3.0, we used to use SQL context dot. Now we don't need to write that actually. So directly we can use Spark dot create data frame. That's it. Spark dot read dot CSV, Spark dot read dot Parquet. So like that, everything you can create, all the data frames you can create on top of Spark object only. Spark is just a wrapper class of all the context that we have. Okay. So data frame equal to like similarly how we have written like RDD equal to in the same way, DF equal to, you can take any variable name here. It's not mandatory to write every time DF here. So like Siva equal to also you can write it. No problem. Okay. So DF equal to Spark dot create data frame of data. This data I'm giving as an input to this one. Directly you can write this list here. No problem. That's what we used to do in RDDs also, right? Okay. Similar thing we can do here. Now this is just a creation, data frame creation, I can say. If you want to see the data from that data frame, actually, we have to use show command. In PySpark, in pure Spark, actually, only show command we use. But in Databricks, we use either show command or display command. Mostly 90% of the cases we use display command only. I'll talk about the differences between the show command and the display command once we get into the Databricks UI. Once we understand about the Databricks UI, I'll talk about that one. For now, for the entire for all these data frame concepts, you have to use actually show command because display command is not supported by this one. I don't know, like in Spark 4.0, they are supporting or not. Let me check that one. So let me check that. Display in Spark 4.0. 4.0 is actually. Mm, there are some new features are there actually. Control F. Oh, I think it's not there. So still we are using the um, show command only, I guess. Yeah. Still these guys are using this one only. Okay, anyway, fine. But in Databricks, actually, we use display command or show command. Anything is okay, but mostly we used to use actually display command. Mostly. And we can use show command also, no problem. I'll tell you the talk about the differences, why we explicitly use this one,
I think Shiva
display
is
command.
actually with did play instead of display. Maybe
Oh,
that
really?
is. Yeah.
Display only, right?
Oh, okay. Somewhere.
Yeah, fine. Okay, so let me try to create the data frame here and see what is the output you're going to get here, how we are getting the output. Now it is executing now. See, we got the data like this. See, this is not a table. Is this not a table? See, your actual RDBMS table also looks like this only, right? So you'll be having columns here and you'll be having rows here, right? Columns 1 and 2. These are all the rows, right? See, currently I've taken only one object here. That is the reason we are getting only one row. If you take here one more object, let's say, comma, I can take here Siva, comma 24. I'm taking here. Okay, now Siva, I'll just try to put it in single quotes here because that's a string. If I try to execute this one and see what is happening here.
మీరు ఎక్కడి నుంచి వస్తారు చెప్పండి.
Okay. So Miller 25, Siva 24, both we got here. Okay. So in data frame point of view, these two are the records. These two are the records. Okay. Anyway, so what happened here? We got the column names as _1, _2. That is the Spark default behavior actually. If you don't specify any schema to this data, right, then by default it considers the column names as _1, _2, _3, and so on like that. How many our columns are columns are there? Those many numbers it will consider. Okay. But Shiva, how do we pass that schema? How do we convey to Spark, hey, this is my employee name, this is the age of the employee? How do we convey that? So you can pass that one here. Okay. Simply you can mention here EMP, okay, EMP number, comma, EMP age or age, whatever you want, you can take it. Employee number, employee age. Okay, since these two are strings here, I'm just trying to put it in single quotes here. So that schema, we need to put it in a list format here. Okay, I mean, we never ever mention like this. I mean, I'm just telling you. This is also one of the way. Okay, let me execute this one and see what is happening here. Now see, employee number, employees, age are taken as column names or not? Yes. Got my point? Now data frames are easy or RDDs are easy?
With one command, what we can fetch?
Sorry, sir.
Just one.
At least see, but just by seeing this as a table, right?
Yeah.
You'll feel happy, right? In
Yeah.
that way, I'm asking.
Mm.
See, in RDDs, everything is like either output, either you're going to get in a list format, tuple format, dictionary format, like that, right? But here, at least you're getting output in a table format, right?
But
Which
it
we regularly use in our real-time cases.
look like a familiar. That's it.
Ah, okay. Anyway, so this is one way to actually create pass the schema to that data frame to the data icon to the data frame command. There are different ways are there actually to create to pass the schema like this. Okay, so one more way is let me copy the same command and let me execute this cell. Create this cell. What I will do is I'll simply mention within single within single quotes. Alright. Within single quotes, what I can do is um, see here. Okay. Before that one, okay. Before that one, I'll tell you one more thing here. Okay. So here df dot, if at all if you want to see the schema of this one, schema of this one. So what command we need to use, print schema. This is very important command. Print schema. This is the command we use actually to see the schema of the data frame. What columns are there, what data types are there. Like if at all if the column is nullable constraint or not. All those things we can see with the help of print schema command. We regularly use this command real time, regularly every day. I mean, if at all if you want to know the schema of the data frame. if you're writing it. Okay, let me execute this one and see the output of this one. See, this is the data output, and this is the print schema output. Okay, see, this is the employee number is the one of the column, and its data type is string, and nullable equal to true. Column can be nullable or not. So in while creating the table, we use actually not null constraint, right?
Yes.
Same thing here also. If you say nullable equal to false, then indirectly you're enforcing that not null constraint. Okay, nullable equal to true means column value can be nullable. You can have null values also in that particular column. If it is false, you cannot have the null values. That means you're enforcing that not null constraint. Okay, so print schema is a regularly used command, I can say. If at all, if you want to know the structure of the data frame, I can say. How we are calling it as a table structure in RDBMS, the same way data frame structure, I can say.
Why it took age as a long?
I'm sorry.
Why it took employee age as a long data type? It's a number, right?
That is the default way it is considering. Okay, we can control that one. I'm going to talk about my next concept is that one only. If at all, if you want to control by default, it considers like that. It infer the schema actually. It scans the data. Okay, based on that, it takes the default data types.
Okay.
Okay, now if at all if you want to control that one, what we can do is we can pass that data types also in the schema. So how we can do that one is my first schema is actually my first column name is actually employee number. We can mention that one with space. Okay, we can simply mention string here. Okay, comma. What is that second one? Age. I'm taking
I'll
here space. Let's say integer. I'm taking here, or small letters also we can take it. Uh,
EMPH.
Anything. Age is also okay. Or EMPH also I can take it. No problem. Anything is okay. Okay. The employee age is only for this particular one. Now I'm taking the first data set right here.
Okay.
You can take anything, whatever you want here. Okay. Now let me try to consider the print schema command here one more time, and let me execute this one and see what is happening. If everything is correct, then it will try to display the output. See here, now it is considering integer format or not.
Okay.
You can control that one here. So that is in your hand. If you don't if you don't want to infer the schema by Spark and give the default data types, you can control from your end. That's what I wanted to say here. Not only like this, girls, you can also give like this. You can also give like this. Colon symbol also you can use. Let me execute this one.
And we have multiple ways to do it.
Multiple ways are there. The, to be frank, we don't use these approaches. We have one famous approach is there actually that we are going to use. Okay. 1 second. Just a second. Okay. So we can give like this also schema. We can pass the schema like this also, and we can pass the schema like this also. Okay. We don't use, to be frank, these two approaches. Let me talk about that the other approach also. Okay, I'll talk about that the other approach bit later. Before that one, I wanted to give a conclusion here. I am taking the Python local objects here. Python local objects here. Okay, and I'm creating a data frame on top of that one so that it is creating a data frame. Okay, this is the first approach. I'm taking the local object, I'm creating a data frame on it, on top of it, using create data frame command. You can use pandas data frames also to create to create data frame, and you can convert that pandas data frame into Spark data frame. That is also one more approach. If you want, I can show you right away. But let me take the perplexity help here. One second, just a second. Create a pandas data frame and convert it into Spark data frame with simple data. Just query this. Just give that one, prompt to that one. So it will give the very simple commands. Now see, name, age, how it is taking. Okay. PD dot it is taking. Now I'll try to take, this is enough for me. This is enough for me. Okay. I know how to convert that into pandas data frame. So we'll simply use here Spark dot create data frame or panda data frame. So we don't need to write all these comments. We already have written right in our command. So we'll simply use that one. So what I was trying to say here is I'm simply taking I'm trying to create a data frame using pandas. So for that, I'm just trying to import pandas here. PD is, I mean, I just alias name here. I already told you, right? Like we can take the alias name also, right? For this one, for the modules. So for pandas module, I've taken PD here. Okay. So data I've taken like this: name, alias Bob, Carol, like this I've taken. Age I've taken 25, 30, 22 like that. Now I'm trying to create a PD dot data frame of. This is the pandas. This is the command to create a data frame in pandas. See, Spark data frames. They took the inspiration from this one only. They're just differentiating these commands here. That's it. Here they are mentioning create data frame. Here they simply mention create data frame. That's it. Okay, but execution model is different here. Execution model is different here. That's it. But commands are same. Backend execution is little different. That's it. Now let me try to create a pandas data frame here. Yeah, I think, yeah, it got created here. Now what I will do is Spark data frame I'm creating here. That is, I'm calling it as the SDF, Spark data frame. You can take any name here, no problem at all. Okay. So here I'm writing create data frame of, this is what we do in even real time as well. Even in my project also, we are doing the same way. Sometimes we read the data using pandas data frames and convert that into Spark data frames and do the operations. Okay. So now let me try to uh, uh, write the show command on top of this one. So yes, sdf dot show. I can write it like this. Something is wrong here. Create data frame is wrong. Create data frame of PDF. That is correct, right? What did I do wrong here? Copy, paste this. Same, right?
Same.
Spark dot create data frame, right?
Oh, sorry. I missed that. Okay. Spark dot. Okay. I missed that. Yeah. Now see, we got the data or not? This is what I was talking. So using local objects, that means Python local objects also we can use, or you can create a pandas data frame and you can create a Spark data frame on top of that. Anything is okay.
So
Both
here
are local
data
objects only. Yeah. Sorry.
in the data frame means here they are creating the data in a tables in the backend, temporary tables kind of.
It's a kind of, okay, this data is actually stored in a RAM memory. Once the cluster is removed or once the cluster is off, then this data will go off. See, we never ever store the data in a RAM memory. The
Yeah.
RAM which we use in cluster only for we use only for processing the data. That's it.
Processing.
Temporarily, it stores the data. Of course, that I agree. That I agree. Okay. See, we don't like store the data like this. We ultimately, eventually, we write this data to some target.
Yeah.
Okay. Yeah.
Shiva,
So
here we need to follow indentation for pandas.
yeah, of course, of course, of
Okay.
course, of course. Python follows the indentation, right?
Yes, yes.
Yeah, see, Pandas also Python package only. Pandas
Yeah.
is just one package, one module in Python. That's it. Got my point?
Yeah.
Hmm. You can slowly explore that. Or if you want me to do that one, I can also do that one. Pandas commands also at the end of the course. If you want me to discuss, I can do that.
Okay. Sir.
Hmm. End of the course, not now. Okay. Okay. Yeah. The first approach is over, guys. I was talking about these four approaches, right? Yeah. First approach is over. Second approach, RDDs. Now tell me, how did we create actually pair RDDs yesterday? Pair RDDs, how did we mention that? Pair RDDs, and how did we create a RDD on top of that? Come on, help me. If you really practice
Evaluate.
that one, come on, help me. So let me take the same data. Can I take the same data like this?
Yes.
Yeah. These are all pair RDDs only, right?
Yes.
Okay. Now come on, help me here. RDD, right? So RDD equal to, or RDD1 equal to, you guys are habituated to that one. Okay. SC dot, SC dot,
Parallel.
uh, pa parallelize of data. Okay. Data. Spelling is correct? Okay, let me
Wrong.
check that one.
Double E. Double E.
Oh, okay. Double R we got here. Double A also we got here. PRLLR.
PARALL.
Okay, sorry. My bad. Yeah.
E
Parallels of data. Yeah.
LLE
Oh, I was
LI.
LLE.
missing. Sorry. Okay.
L.
Now
One more L.
one more L. LL I
After,
used, right?
after
LLE.
LLE LIG.
Oh, sorry. Okay, sorry. RDD1 dot. We are. Let me try to use actually print of type of. Okay. RDD1. Okay. This is what I wanted to check actually. Okay, first let me check that one. See, it is creating a Spark RTD in the backend. Now, what we have to do is same way how we are converting the Pandas data frames into Spark data frame. The same way we can create actually like this. So Spark dot create data frame of RDD we can mention here. That's it. Now it's
RDD1.
RDD1. Sorry, RDD1. Okay. Now here df dot show command we need. Instead of collect, we are just using the show command here. That's it. Okay. And after that, it is executing still. Okay. Now, if you want to see print of whether it is clearly creating the data frame or not, if you want to see that one. So df type of df, right? So type of df we can write it here. Okay. Execute this and see what is happening here. Now see, it is creating a Spark data frame. See, PySpark.SQL.data frame. SQL is a package here. Inside that one, data frame is a module. Inside that one, an object name is data frame. It's creating a
Oh,
PySpark data frame object.
can you write correct statement as well?
Yeah,
RDD2
we
equals
can
to
happily write it.
RDD1.
No problem at all. You need to understand how we are getting the output. Okay, collect. Sorry. Now let me execute. You can use collect on top of data frame as well. No problem at all. Now see the output. No, print we need to use, guys, because it is overwriting actually the output. Now we'll see the output definitely. See how we are getting? We are getting row objects or not? A row of _1 equal to Miller, _2 equal to 25, row of _1 equal to Siva, row of _2 equal to 24. How we are getting? What it is creating actually, what it is giving in the backend? Row objects.
Okay.
Rows.
So in data frames, you are properly showing names and
Data
formats.
frames it is showing properly. If you write collect backend, it shows the rows on
Okay.
row objects. This is nothing but your column and its value, column value, column value, column value. Indirectly key value pairs here. Indirectly. Okay. Hmm. Okay. Anyway, this is also one more way to convert the RDDs into data frames. Okay. Yeah. So that is about the. We can use 2DF also. Nowadays, we are not using that one, to be frank. We can convert the data frame into, sorry, RDDs into data frame using 2DF also. So I'll talk about that one. We have one use case actually. Not this 2DF. We have one more approach is there actually. Somewhere I've written that. Okay. I'll talk about that one, not now. Anyway, I have to discuss that. Okay. So that is about the basic approaches to create RDD. Okay. Now, next one is actually, and one more thing I forgot to mention, guys. We can take actually, uh, you can use the dictionary also. Somewhere I have that example. Let me take that. Where is this? This is the one. So I can use this approach as well. I mean, we never ever use this one. Don't worry. I'm just telling you different question. See, previously we were using key value pairs, right? Now instead of that one, directly we are getting giving here dictionary here. Name Alice, age 25, name Rahul, age 30, city Pune, like that. Okay, on top of that one, Spark dot create data frame of data. Okay, now df dot show. Now see what is that output you're getting. So in this dictionary, we don't have city column, but here we have city column. Now see, in the city column, we are getting null in the first record, and we are getting Pune in the second record. We can give like dictionary also here in place of key value pairs. See, that is the reason why, like I was discussing pair RDDs yesterday. If you don't understand that pair RDDs, you don't understand this one here. Siva, what is the linkage? See, I have written here what pair RDD or not? Pair RDDs concept only, right? Indirectly or not? Yes.
But Shiva, here column names are not giving in order, right? If you
Which column names? This,
like name after age city came, right? But in the output age name city in different order.
don't worry about that. Don't worry about that one.
But when we created data frame, right? That we are getting in exact column order, right?
If you want to control that one, you can control here, no problem at all.
If we want to control that, we can.
You can control that anytime, no problem. You can do that. Okay. Not here. In the actual tomorrow or day after tomorrow, I'm going to discuss about that. We have select command on top of this one. What we can do is simply you can do like this: df dot select of, okay, name comma age comma city. You can take like this. Okay, and you can assign this one to df2 equal to, now df2 to dot show we can take df2 dot show command we can take. Okay, execute this one. So name not found. Okay, what we need to take is here we can take the column names in a list format as well. So we can put that one like this, or call off also we can take. I'll talk about that one also. See how we are getting here. You can
Yes.
control that any point of time. No issue with that.
Yeah. Okay. Thank you.
Okay. This is very simple. Normal select your SQL select command only. There you will select name, comma, age, comma, city, right? Here also we do, but we put it in a list here. Or we can do call off also. I'll talk about all those things later.
But but everything will be in either list or tuple only, right?
Uh, it doesn't need to be like that. Maybe once I discuss about the data frame transformations, right? There we'll understand it clearly. Every
Okay.
time it need not be in tuple format or like a list format.
Okay. Okay.
Okay,
Sure.
different approaches are also there. I'll talk about that one. Okay, anyway, yeah, we are good with this. Mm, what else has been okay? So before we move on to the third approach, I wanted to discuss about the data types in Spark, and after that, the famous approach to define the schema. Also, I'm going to discuss. Okay, so for that, let me open my slide deck here. So, what are all the data types you know in SQL?
Varchar, string,
Varchar,
integer,
varchar,
number.
char, date, timestamp, long, double, like the different data types are there, right? In the same way here also, we don't have varchar concept, but still Databricks supports the varchar. We in one of my previous project actually, in place of string, I used varchar of 20, varchar of 30, like that I used. Still supports that. Databricks supports that. Spark, I don't see anything such kind of data type, but Databricks supports that. Okay. So string data type we have. If at all, if you want to import that string data type, actually, oh, sorry. Import that string data type, you have to use this import command from pyspark.sql.types. Data types indirectly. Types means data types. Import string type. Okay, so string type stores the data, this kind of data, hello world kind of data. I mean, string data, I can say simply. Okay, I mean, I'm not like discussing too much on that one. I'm just high level giving you that. So we have byte data type also. Mostly we don't use this one much, the regularly used one. But if you want, you can use that one. So 8-bit signed integers, if at all, if you want to use, you can use this one. Okay. Um, I mean, for small numbers, I can say. Mostly we don't use this one. Don't worry about that one. Short data type is nothing but a 16-bit integer. That means you can store the data from -2 power 16 to +2 power 16. If you want to store the data, you can use uh, uh, this one actually. Short type. Integer type is 32-bit signed integer. That means integer is actually I don't remember, -2 power 32 to 2 power 32. That many numbers it can hold. That many numbers. If you want to like have beyond that values, you need to go with the other data type called long. It's a 64-bit signed integer. Okay, so you can store 2 billion, -2 billion to total 2 billion, -2 billion to +2 billion. I think it will store 2 billion. So we have one more thing, that is bigint is there. I think 9 billion is the limit for that one. Bigint. Bigint and long type both are same, I guess. I'll check that one and let you know. Mostly we use Bigint actually in Databricks. Okay. Okay. So next one is, if at all, if you want to store the float data types, we can use float happily, no problem with that. I mean, similar to your SQL only, guys. No, not it's not a complex at all here. Okay, we can use even double also. Float is actually 32-bit floating point numbers. This is for 64-bit double precision floating point number. So in our real time, if at all, if your source data is having actually any decimal values and all, 99% of the cases I use double type only. Double or float, both are same. But this can hold more values, this can hold less values. That's it. That is what we need to understand. Okay, clear? Even we can use decimal also. Mostly I never use this one. Whenever I use decimal, I used to get some issue in Databricks. Okay, that is the reason why I stopped using this decimal data type in Databricks. So it will not take it was not taking the precision values actually, scale and precision values. Okay, so that is the reason why. So this is also like used for storing the decimal values, but I don't recommend this one to use in your projects. You'll get into issues definitely. Okay, so in place of that one, you go with the double data type always. Next to Boolean, if at all if you want to store this kind of data, actually we can use true or false. If you want to store, we can go with the Boolean data type. Okay. And next one is date data type. If you want to store this kind of data, dates related thing, then we can use date data type. If you want to store the timestamp data type, this kind of data, we can use the timestamp data. So timestamps and dates, I'll take a special class for that one. I mean, special means like at the end of the data frames, I'm going to discuss about that one. How to deal with all the timestamps in Spark, everything I'm going to, every function in the timestamp related one, I'm going to discuss because in day in day out, like we deal with the timestamps every day. We deal with the timestamps in real time. Okay, so the next one is array data type. If we have this kind of data, we can take that data type as array data type. Okay, so if at all if you have this kind of data, map data type we can use. Okay, and now last one is null type. We don't use this one. That's okay. Now last one is binary data type. Even if at all if you're handling with any binary data, we can go ahead and use this one. But I never ever use this one, to be frank, in my experience. Okay. Calendar interval, yeah, of course. If you have your calendar interval data like this, of course you can store this one in a string format as well, guys. No problem at all. But specifically, if you want to explicitly, if at all, if you want to store that in a calendar related data type, you can go ahead and use this one. Mostly this kind of data we deal with these strings only. We mostly use the string data type one. Okay. Yeah. So that is about the data types at high level. Now we need to understand about the how we can create the schema with the help of all these data types. Okay. Now, I was telling you, right, some time back. So we have to pass the data schema to the data frame command actually in a list format or with a space or with the this one colon symbol also we can use, right? But we never ever use that approach actually. What we do here is, let me click on this one, use this one here. See, we are almost all the times we are going to use this approach only. Okay, so I'm just trying to import all my the corresponding data types here. String data type, integer data type, and we need to import these two as well, these two objects as well, struct type and struct field. So what we need to do is fields equal to struct field of, see, column names we call it what? Fields, right? In a table. Just
Yeah.
remember in that way. Just remember in that way. So how we are defining at the time of table creation in SQL, in the same way you try to define it. That's it. But in a list format, that's it. Okay. So struct field of whatever the column name. See, in SQL, how do you create the table? Create or replace table name. Okay, let's say table 1. Okay, and after that, open the bracket here. And what you will do, column name you will mention. Let's say column name is column 1. And after that, what do you mention?
Data type.
Data type, right? Let's say data type is string data type, right? So you'll mention string. And after that, what you'll mention? Not null,
Not null
you'll
is
mention, right?
by constraints.
Null. Let's say if you mention null like this, the column value can be nullable. Indirectly, constraint we are applying on top of this column. Same way here also, just mention the column name in double quotes here. And after that, whatever the data type you have, you wanted to create. See here, we have short form of data types and like long form of data types are also there. If you want, you can use either of the approach here. Okay, this is the long form of data type, I can say. If you want to use short form, str also we can use here. Okay, string also we can use here, not str. Okay, I'm going to talk about that one also. Okay, so string type I'm using here. Always you try to use open close bracket here, parenthesis here, and at the end whatever you're mentioning true or false you can mention, or even if you don't mention, by default it takes true only. That means column value can be nullable by default. Even if you see, even in SQL also, if you don't mention this null, what happens? Can we maintain the null values in this column? Can we?
Yes.
Yes, we can. We can. In the same way here also, this true is optional actually, but these two are mandatory. Column name and the column data type. Okay.
Now,
So, mm,
one doubt, Shiva.
mm.
Here you have mentioned string type and integer type, right?
Oh yeah,
Those two are you have mentioned in the import statement as well in the first line.
correct, correct, correct.
So if I use anything, you have to mention in the import statement.
Yes, correct. That's what I'm about to say.
Okay.
Whatever you're writing here, you need to import them. Or what we used to do is, instead of writing all those things actually, what we used to do is in real time, okay, sorry, I'll simply use here star. That's it. You can execute this one. Fields equal to indentation we need to follow. That is the reason why it is throwing error. Now schema also we need to move it to the left side. Now let me execute this one. See, the schema object got created here. Okay, now I wanted to attach this one to my data frame. So where is my data frame command actually? Here is my data frame command, right? Now let me copy this one and try to put it here after this command.
Now you mean to say we are creating table, we are now inserting the data in the table.
No, we are not inserting anything here.
I mean,
Okay, you're saying that where are we inserting the data into the table, right?
yeah, I mean, if you run it, okay, in section 22 is creating a table, right?
No, we are not creating the table. We are creating the structure of the table, data frame structure indirectly. See, my point is here, we are passing the schema like this, right? Here, we are
Mm,
passing the schema in a list format, right? There
mm.
is one more famous approach we have to use to pass the schema. That is what I'm trying to discuss here. Got my point?
Mm.
Okay, this approach, mostly used approach in real time is this one only. Because we have more control here. We can define the like the data types the way you want. You can control the constraint as well here. Everything you can control here. That is the reason why we use this approach. Now I can execute this one happily here. Fields I'm giving string type and integer type here. Now let me execute this one. See the output here. What happened here? Structure field object has no attribute encode. Where is that encode we have? Where did we get that one encode? Oh, sorry, schema. Sorry. My bad. So see, after defining the fields, actually, you need to pass it to the struct type object so that it is going to create a schema on top of it. Okay, that schema variable name I'm just passing here. Now let me execute this one here. Now see, it will display the data properly here. Previously I used fields. I'm sorry for that. Okay, we have to use the schema here. I mean, you can use any name here. Just for understanding purpose, I use the name here as schema. You can use Siva also here. No, that's Siva. You just pass here. It is just a variable here. That's it. Now see, a string integer. You can take like this also, guys. Okay. Now whatever copy and put it like this also. That is also fine. Now you can define like we need to import them short forms. We can't we use that one here? Short form also we can use. Mm, we can use actually. Okay, I'll check this one. I'll check this command. I'll get back to you on that. Okay, short forms also we can use actually, but might maybe not in this way. Okay, I'll let you know that. So anyway, we have that long form, right? So we'll try to use that one only. Okay. So that is about passing the schema. See, one more approach is also there actually. One more approach means same way, different variation. That's it. So the different variation is we can use this approach as well. Structure type of directly we can use instead of like creating this list outside of the struct type and passing that list to the struct type. Directly we can define inside the struct type here, struct fields. Okay, so this is one more variation. We have one more variation also. You create a struct type object separately, and you try to like add the struct field. Each and every field you can add it here. This is also one more approach actually to create a schema. So schema dot add of that struct field of that. See, indirectly you're adding the elements to this one here. That's it, to that object. Getting my point? Add is just a method on top of this object.
Mm.
How we have append method on top of list, right? The same way on top of this object we have a method called add that adds the fields. Okay. Last approach, we can write like this also. This is last approach. Structure type object we can create separately, and we can simply write chaining of adds here. Add of employee number, everything we can mention in a single command here. Dot add of dot add of dot f. Any number of like columns we can mention.
Out of these many things, which one will use most frequently once we
Oh,
get it?
so approach is only one, but different variations are there here.
I mean,
Are you getting my point?
yeah,
This
yeah.
one
Which?
we use mostly.
Okay.
It's easy to remember, easy to write it also. See, why I'm telling these many variations, right? See, you are like getting into the project which is already developed, right? Somewhere, if you see this kind of comment, you should not like you should not surprise there.
Okay.
Okay, so you need to understand. Okay, this is also one more way to create a schema. See, the more you know the variations, the more you'll understand the code easily in real time. You have to understand the code. There is no other go. If you are writing it first time, that is secondary. But somebody else have written that code and you have to do the modifications on top of that one. You have to understand the code first. Mhm. Okay. So this is about the data types and the structure field schema one. Okay. So tomorrow I'm going to talk about how we can read the data from the CSV and what are all the different options are there in that CSV API. That's what we are going to understand. Okay. Yeah. So that's all for today.
So this you said some 41 API something, right? That is not
Mm-hmm.
yet started, right? Still.
Not yet started. Tomorrow I'm going to start them. Okay.
You okay? From day before onwards, you are uploading videos privately, right? And you are yet to
Yeah,
check.
yeah, yeah. Correct, correct. Are you guys are not able to access the videos?
There is no links at all, right?
Yesterday only I did not give that one. Day before yesterday I gave, right?
No, no, sorry, but that might be I didn't check it.
Okay, okay, no problem. Yeah, you can check that.
Yeah.
Yesterday I did not upload. I'll upload today's video and yesterday's video together. Okay, let me stop recording the session.